Hello, my dear students. Welcome to IMS GATE Academy. I hope you are having a great day ahead. Students, you are enjoying the sessions on the foundation course. As part of this activity, we are delivering the foundation course for all the branches IMS India YouTube channel. My dear students, when I talk about geotechnical engineering, we are covering all the topics right from the first chapter to the end of this chapter. If you have attended the geotechnical course, at least you can have an idea what actually the GATE questions, how they are asked in the GATE exam. So my dear students, so let us discuss today's class, how do you classify a soil? Now my dear students, today's topic is nothing but soil classification. Today's topic is soil classification. Now, why do you want to study this topic, soil classification? Why do you want to study? These students, according to different criteria, according to the application of engineering, suppose according to the transportation, the soil will be good if it is having good bearing capacity, because there can be a differential settlement in roads. So we have to avoid the differential settlement in case of transportation. But as I told you so many times, the entire structure will be bared by the soil. Suppose whatever the load which is happening on the slab will be transferred to the beam, then to the column, and then to the footing. And where does this footing rest? This footing rests on the soil. So which soil is suitable? And based on the soil also, the amount of water, at what level you will find the water. These things also you should. So let us understand what actually do you mean by soil classification. So here I will be explaining you what do you mean by soil classification and how do you classify the soil. So my dear students, the basic agenda here is based on the particle size. Based on the size of the particle, first initially the soils are classified based on the size of a particle. So when you talk in a broader picture, my dear students, you will talk about the fine-grained soils and you will talk about the coarse-grained soil. But what is actually fine-grained and what is actually coarse-grained? In simple, loose words, if the size is more, then it is coarse-grained. If the size is less, then it is called fine-grained. But in fine-grained, there can be again soil particles of clay and silt. And if you see in coarse grain, it can be gravel or sand. Very good evening, Atul. Very good evening. Okay, so here, based on the particle size, how do we classify the soil? Suppose here, my dear students, if I take a soil particle, sieve size as 2 micron, whatever the soil below 2 micron, we call it as clay. And after clay, up to 75 micron, in terms of mm, up to 0.075 mm, it is silt. So, my dear students, whatever the soil which comes under 2 micron and 75 micron, we classify the soil as fine grained. Very good evening, Sai Srujana. Very good evening. Okay, and I hope you are attending the lectures daily. That's a good part from your end. So here when I talk about the fine grain, we have two soil particles. Sorry, two types of soils. One is clay and other one is silt, and both are related to the fine grain. When I see 0.075 mm to 0.425 mm, then we call it as fine sand. Then we call it as fine sand. And my dear students, 0.425 mm to 2 mm, we call it as medium sand. And up to 4.75 mm, from 2 mm to 4.75 mm, we call it as coarse sand, or the size of the sand particle will be more. And more than 4.75 mm, we call it as gravel. And more than 80 mm, we call it as cobble. And more than 300 mm, we call it as boulder. So here it is quite a simple thing. Srujana, here it is quite a simple thing. What I would like to tell you is, If you observe the soil particle size, based on the particle size, the soils are classified. As I told you, my dear students, when the soil is small, then there can be void ratio is high. When the soil is coarse, the void ratio will be less. So based on the particle size, we are going to classify the soil, and based on the classification, we can have an idea about the soil particle. So this is a very important parameter, my dear students. So when the particle size up to 2 micron, we call it as clay, and up to 75 micron, we call it as silt, and 75 micron to 4.75 mm sand, and 4.75 to 80 mm gravel, and 80 to 300 mm cobble, and more than 300 mm boulder. Am I clear, my dear students? So whenever you are classifying a soil, the basic agenda is, first, we have different methods. But first thing, you should give an idea to the size. So the first priority to classify a soil is the size, and that size, how you can do using the sieve analysis. Am I clear? Can I move on? Okay, let us see. Sir, see, I'm a transportation engineering. In a transportation engineering, we have this enthusiasm to identify the soil which is suitable for payments. We have different organizations, my dear students. When I talk about ASHTO, American State Highways Transport Officials. What is ASHTO? American Association State Highways Transport Officials. And we also have HRB, Highway Research Board. And we also know about the PRA, Public Road Administration. So all these three organizations are related to what, my dear student? All the three organizations are related to the payment. So American Association State Highways Transport Officials, or Highway Research Board, or Public Road Administration, their agenda is same. They want to identify the soil. They want to identify the soil which is suitable for payment. They want to identify the soil which is suitable for Now, my dear students, they classified the soil into 7 groups. These organizations, they have classified the soil into how many groups? 7 groups. And these 7 groups are what, sir? A1, A2, up to A7. They have given the names to the soil as A1, A2, A7. Srujana, are you following? Sai Srujana, are you following? How many groups are there? Soil is classified into 7 groups. And here we have A1, A2, up to A7. Now see, students, here suppose if you have got a soil A1 and you have got a soil A2, which is the best soil? Out of these two, very good, Srujan. Out of these two, which is the best soil? So here I will tell you, smaller the number, better is the soil for payment. But sir, smaller the number, better is the soil for payment. Smaller the number, better is the soil for. Okay. When I talk here, now tell me which is the best soil, Srujana? Is it A1 or A2? So definitely smaller number will have. So A1 is the best soil. So what they have done is, they have classified the soil into 7 groups, and in that 7 groups, they have identified that whichever is the smaller in number, that is the best soil for payment. Now suppose here comes Sai Srujana will ask me one doubt. Sir, first suppose if I have got A2 soil and my friend also got A2 soil, then which is the best soil? Then which is the best soil? So there comes a concept called group index. Here comes a called index. What is the purpose of group index is, it will identify the quality of the soil. It will identify the quality of the soil within the same group. It identifies the soil, quality of the soil within the same group. Now, my dear students, you will ask me, on what basis you are going to classify this soil? There should be some base to classify this soil. Group index is used to indicate the quality of the soil within the same group. Sir, now on what basis you are going to classify the soil? Now here comes, it is based on how much is the percentage of soil passing through. How much is the percentage of soil passing through? 75 micron. How much is the percentage of soil passing through 75 micron? And also liquid limit, WL we call, and also plastic limit. So as I told you, why do you want to study about consistency limits? I told you, these consistency limits will help you to classify the soil. So whenever you are finding the liquid limit and plastic limit, it helps you to identify the soil. It helps you to classify the soil. So group index is used to indicate the quality of the soil within the same group. On what basis you are going to classify? Based on how much soil is passing through the 75 micron. Because based on the portion, how much is the soil passing through 75 micron, you can understand what portion is fine-grained. And you can understand the liquid limit and plastic limit. Thereby, how much water content, you will also have an idea. So here, my dear students, group index varies from 0 to 20. The group index varies between 0 to 20. And remember, my dear students, smaller the group index, better is the soil for payment. Suppose if Srujana has got A1 and I also has got A1, my number is 17 and Srujana's number is 15. And then A1, Srujana is the best soil. Are you getting me? So remember the word, smaller the group index, better is the soil for payment, my dear student. So group index is used to indicate the quality of the soil within the same group. That makes a lot of sense. Okay. Now, my dear students, we are talking about the soil classification system. So actually, we have a soil classification system called Unified Soil Classification System. Unified Soil Classification System. Now, when I talk about Unified Soil Classification System, this system is also known as Airfield Classification System. This system is also known as what, my dear student? Airfield Classification. Airfield Classification System. So here, my dear students, we have the first system is Unified Soil Classification, and this system is also known as Airfield Classification System. And this system was discovered by Casgradus. This system was discovered by Casgradus. Now, my dear students, again the same question. Suppose you are telling some system. So if you are telling SI unit, if you are telling MKS unit, there will be some system, meter, kilogram, like that. Similarly, here also, on what basis you are going to classify the soil? Remember one thing, students. If you are really enjoying these sessions, it's my sincere request on behalf of the IMS India, please share this session to all your friends, because the real GATE aspirants will be very fruitful. We are not only coming with civil engineering, we are coming with all the other subjects, all the other branches also. Just share this link, and that will boost up our confidence, and we'll be delivering more and more lectures. So here, when I talk about the airfield classification system or unified soil classification system, on what basis you are going to classify? The first one is the particle size distribution. The first one is particle size. You might have read in the textbooks like grain size. Grain is nothing but particle. So based on the size of the particle, that is particle size distribution. Next one, plasticity characteristics. Sir, what is the meant by plasticity, my dear students? It is the property which allows to deform without rupture. When I talk about consistency, it is the property which does not allow to deform. But in plasticity, the soil is allowed to deform without rupture. So based on plasticity characteristics, and also compressibility. And also what, my dear students, I talk about the compressibility. So what actually is compressibility? So here in compressibility, my dear students, we have two voids in the soil. One is air and other one is water. If you remove the air, how do you remove the air? When you do the compaction. When you do the compaction, to improve the shear strength, we'll be doing the compaction. If you remove the water, you might have heard about Leaning Tower of Pisa. The main culprit is consolidation, and that happens due to the squeezing of water. The removal of water is known as consolidation. And remember, my dear students, consolidation is a term like creep. You might have studied in strength of materials. What is a creep? It is a long-term deformation or deflection under constant. So it will not happen immediately. So consolidation is a very dangerous sign, my dear student, because it happens for years. Actually, in olden days, when you used to have a wells in your household or anywhere, if the well is not properly compacted, there can be squeezing of water and there can be a differential settlement. In Leaning Tower of Pisa also, you observe this. Friends, are you following? Now here, on these three bases, we are going to classify the soil. One is the particle size distribution, another one is the plasticity, and another one is compressibility. What do you mean by compressibility? It is the removal of both air and voids is known as compressibility. Surajana, is it clear for you? Now, let us see here, almost according to this soil classification, almost soil is classified into how many groups? 18 groups. And remember, see students, we have in India called Indian Standard Soil Classification System. Indian Standard Soil, Indian Standard Soil Classification, Standard Soil Classification. See here, students, Indian Standard Soil Classification System is also derived from Indian Standard Soil Classification, also derived from where, sir? Hi, Hamant, hi. So, Indian Standard Soil Classification System is derived from where? It is also derived from the Unified Soil Classification. It is also derived from Unified Soil. So, Indian Standard Soil Classification System also will depend on the same parameters, that is grain size distribution, plasticity characteristics, also compressibility. Okay, is this clear for you now? I hope you are clear. Now let us see, students, let us understand the term. How do you classify the soil? That is one thing you have told, Unified Soil Classification System and Indian Standard Soil Classification. See, my dear students, if I have a soil called clay, how do you represent the soil clay? Anyone, my dear student, how do you represent a soil called clay? Clay is represented by C and sand is represented by S and gravel is represented by anyone, Hamant or Srujana. How do you represent gravel, Amma? How do you represent gravel? Gravel is represented as G and silt is represented as, at least tell me silt, how it is represented? Silt is represented as M. Okay? So how do you, very good, Haman. So here, my dear students, silt is represented by M. That is the one of the thing. Sand is represented by S. Agree. Now we have different types of soil particles. Clay, silt, sand and gravel. Right? Now see students, when I talk the word, when I told you the word well-graded gravel. So see students, when I use the word well-graded, what is actually do you mean by well-graded, my dear student? Well-graded is nothing but a well-graded can be classified saying that if it contains particles of all sizes. Particles of all sizes are present in a soil sample. We call that soil as well-graded. If suppose some particle sizes are missing, then we say that poorly graded. Now, when I tell you well-graded soil, gravel, how do you represent this soil? Anyone, my dear students, how do you represent the soil well-graded gravel? How do you represent? Can you please comment in the comment box? How do you represent well-graded gravel? Very good, Hemant, very good. So, well-graded gravel is represented by GW. Now, Sai Srujana, first see the logic here. What is the type of the soil here? The type of the soil is gravel. So, you have to name gravel with G. Now, how do you represent well-graded is by W. So, it is GW. Agree? Very good, Now, my dear students, if suppose, if I have given you poorly graded sand, if I have given you poorly graded sand, how do you represent poorly graded sand, my dear student? How do you represent the poorly graded sand? Very good, Srujana, very good. Now you are in the track. The sand is represented by S and poorly graded is represented by P. Very good answer, So here you are clear about the well-graded or poorly graded. I will tell you one beautiful thing here. See student, when you are taking a milk, usually on the basis of fat content, we'll tell the milk is good or bad. Okay? Suppose if the milk is having a good fat content, you tell it is a well-graded milk. If the milk is supposed to contain, or if the milk contains some amount of water, then you can say poorly graded milk. I'm giving just an example. So here, my dear students, there is only one thing, whether it milk. In that milk, whether it is well-graded or poorly graded, you are talking. When you talk about gravel also, you talk about gravel is well-graded or poorly graded. That means, my dear students, please keep this as a note. If 95% of the soil is of same type, means if there is a soil having 95% is gravel only, then we talk about well-graded or poorly graded. Okay? Now see students, we have another concept called silty gravel. Next we have a concept called silty gravel. What does the silty gravel represent? How do you represent silty gravel? I would be very happy if anyone tell me, how do you represent a silty gravel? Silty gravel. What about you, Hemant? GM. Very good. Srujana, to avoid the confusion, I'll tell you. Sir, see, very good, Srujana, very good. Now, how to avoid this confusion, we'll see. See, students, when you move towards that right direction, the composition increases. Are you getting me? So, when I tell you it is a silty gravel, what does silty gravel represent? So, here, my dear students, you should understand that gravel composition is more than the silt composition. When they tell you silty gravel means gravel composition is more than silt composition. If gravel composition is more than silt composition, then we write it as silty gravel. Then we write it as what? We write this as silty gravel. So here, which is more? Gravel. So first write gravel. After gravel, what is the other compositions? It is clear. Now, Srujana, how to work on? If they give you silty clay gravel, they give you silty clay gravel. When I talk you about silty clay gravel, how do you represent? That means, how do you see about the composition? Gravel composition is more than, when I talk about the composition, gravel is more than clay and clay is more than, okay, or you can represent this as CC/GM. That means gravel clay and gravel silty. It's a dual combination. Clear, students? So, in this way, how the naming convention is given to the soil classification. So, I hope you are clear. How do you give the naming convention? Suppose, my dear students, I have given you clay sand. How do you represent clay sand? How do you represent clay sand? I would be very happy if anyone reply. How do you represent a clay sand? Anyone, my dear student? How do you represent a clay sand? It is represented as, yes, very good, very good. Now see, students, based on the liquid limit, see students, this is very important. Based on the liquid limit, we are going to tell whether it is low compressible, whether it is high compressible, or whether it is intermediate compressible. Are you getting, my dear students? Based on the liquid limit value, the compressibility can be identified. See here, when the liquid limit is less than 35, less than or equal to 35, then it is called low compressible. Liquid limit is less than or equal to 35, it is said to be low compressible soil, that is equal to L. If the liquid limit is between 35 to 50, then it is what, my dear student? It is called intermediate compressible. If the liquid limit is more than 50, then it is called highly compressible. So, my dear students, based on the liquid limit value, we can judge whether the soil is low compressible, whether the soil is intermediate compressible, or whether the soil is highly compressible. Am I clear? So, based on the liquid limit characteristics, you can tell whether the soil is low compressible, whether the soil is intermediate compressible, or whether the soil is highly compressible. Am I clear, my dear students? So here you are clear about the low compressible and intermediate compressible. So here if I show you the names ML, MI, MH, similarly OL, OI, OH, similarly you can write CL, CI, CH. So here see students, what is CL? Low compressible clay. What is CI? Intermediate compressible clay. What is CH? Highly compressible clay. Sir, what is O? Forgot to tell you, O is nothing but the organics. O is what? O is nothing but the organics. So here you have ML, MI, MH, low compressible silt, intermediate compressible silt, highly compressible silt, or low compressible organic soil, intermediate organic soil, highly compressible organic. So these are the different types of soil. Agree, students? These are the different types. Now see, students, let us understand an important concept called plasticity chart. And remember, my dear students, this is a very important topic when you are talking about the classification. Because when I see here, this has very important. So let us understand the plasticity chart. Let us understand the plasticity. So when I talk about the plasticity chart, how the plasticity chart looks like. Okay. Now see, students, let us understand this. Now see, students, there is a chart here. We call it as plasticity chart. So the plasticity chart is drawn between plasticity index and also water content. You can write water content or liquid limit. It's a graph drawn between what is IP, plasticity index, and liquid. See, students, always I told you the known quantity will be on x-axis and the dependent quantity will be on x-axis, y-axis. Dependent quantity on x and dependent quantity on y-axis. Now see, students, here, what is this value is? This value is 20. What is this value, sir? 35. What is this value? This value is 50. So here we call this as what? Call this as A line. Call this as what, my dear student? As A line. Now see, students, above A line we call it as clay. C-I-C. Sir, see, how do I give L, I and H? That is important. If the liquid limit is less than 35, it is low compressible. If the liquid limit is between 35 to 50, it is intermediate compressible. More than 50, I wrote it as CH. Am I clear, Srujana? So based on the liquid limit, we are going to classify the soil, whether it is low compressible or intermediate compressible or highly compressible. So here you can also write it as ML or OL, and here you can write it as MI or OI. Here you can write it as CL or OL. So my dear students, you can write above the A line, it is called as clay, and below the A line, it can be silt or clay. Agree? Now see students, at plasticity index 4 to 7, the plasticity index 4 to 7, you see the plasticity index 4 to 7. At a plasticity index 4 to 7, there will be Cl and so understand this concept, student. What I would like to tell you here is, if you have a plasticity index value between 4 to 7, you will have both the nature of clay and silt. You will have both the nature of clay and silt. Agree? If the plasticity index is between 4 to 7, the plasticity index is 4 to 7, it has the dual nature. What is the dual nature is? Has both the properties of clay and silt. So, my dear students, the equation of a line, my dear students, if you are writing any ISRO exam or any competitive exam, this is a very important point. So, when I talk about the equation of a line is given by the formula IP is equal to 0.73 into liquid limit minus 20. This is the equation of the A line and a very important objective question in competitive environment. What is IP? IP is given by the formula 0.73 into liquid limit minus 20, and here 0.73. What is WL? WL is the liquid limit. Okay. Now see students, how do you classify soil? Now they can ask you simple question. This is also a previous gate question also. Classify a soil when liquid limit is 40 and the plastic limit is 20 percentile. 40 percentile, 20%. I'll give you 1 minute of 30 seconds. Anyone, my dear students, I would be very happy if you classify this soil. Classify the soil whose liquid limit is 40 percentile and plastic limit is 20 percentile. Okay? I'll give you 30 seconds. Now see students, first of all, see, please follow the steps of what I have done now. The step 1 here is find out IP. What is the formula of IP? Liquid limit minus plastic limit. That is equal to 40 minus 20. So that is equal to 20. So here the first step is finding out the plasticity index. Now, once you are done with the plasticity index, you have to calculate the second step is the location of A line. Where does the A line is located? Or location of A line. How do you calculate the location of A line? IP is equal to 0.73 into liquid limit minus 20. So here it will be equal to 0.73 to 40 minus 20. So here it will be 20. 20 into 0.73, 14.6, 7.3 into 2. It is 14.6. Agree, Srujana? So here if I draw the graph, the beautiful part of A line is at a location of 14.6. And where does this IP lies? Whether it is lying above A line or below the A line. Whether 20 value is more than 14.6 or less than 14.6. So 20 is somewhere here. So it is above A line. So when you tell, my dear students, above A line, I told you already. If it is below A line, it is silt. If it is above A line, then it is called as what? It is called as. Now, my dear students, Identify the low compressible or intermediate compressible or highly compressible. Now see, what is the liquid limit given? It is 40. So 40 means it varies between 35 to 50. So if the liquid limit is between 35 to 50, what is the soil? Is nothing but the intermediate soil. Above a line, we call the soil as clay, and when the value is between 35 to 50, it is called intermediate soil. So here, my dear students, you can write this soil as intermediate clay. So you can write this soil as CI. Any doubts? Srujana, is this clear for you, Amma? If you can understand the concept, it is a very easiest way. So first find out the plasticity index. Second, find out the location of A line, whether your IP is above A line or below A line. Based on the liquid limit, you can understand whether it is low compressible or intermediate compressible or highly compressible, my dear student. Is it clear? Is it clear, Mama? Okay. Sir, once again I am telling you, my dear students, if you are really liking this session, please share to all of your friends. You can share to your classmates and who are writing the GATE exam, my dear students. Remember, in GATE, geotechnical is a very, very important. Once again explain, sir. Once again explain. Srujana, see here, they have given you liquid limit, how much, Amma? 40%. And what is plastic limit they have given? 20 percentile. Okay. Now, what is IP? IP value is nothing but liquid limit minus plastic limit. It is defined as what? Liquid limit minus plastic limit. So, this value will be equal to 20 percentile. So, what is the IP value you got? Now, tell me. It is 20. Sir, IP value is, this is the from formula or actual IP value. But if you see from A line, if I talk about IP is given by the formula 0.73 to liquid limit minus 20%. So here in this case, this can be written as 0.73 into 40 minus 20. So what is this value? This value is 14.6. Are you getting, my dear student? Suppose if you have a graph, the A line is located at which point? The A line is located at 14.6. Now this 20, whatever the value 20, is it above 14.6 or below 14.6? Can you tell me? It is above 14.6. 20 will be somewhere here. So I told you clearly, when you got above A line, when you tell it is above A line, then what is the type of the soil? Then it is a clay soil. And what is the value of liquid limit here? 40. So when the liquid limit is between 35 to 50, when it is value is between 35 to 50, then we call it as intermediate. So here we write this soil as CI. As it is above A line, we call it as C. As the liquid limit is between 35 to 50, 40, we write it as C. Is this clear, Srujana? Can you quickly respond? Can you quickly respond, my dear students? Yes or no? Srujana, is it clear? I'm just waiting for your reply. Okay. Are you 100% sure? Okay, great. Now see, students, we have classified the soil with the perspective of plasticity chart. My dear students, in objective questions, when you are classifying the soil, don't worry that there can be two things. There can be two answers. then don't worry. The multiple select question, there can be two answers. So you should be very smart. In some case, the soil can be taken as CI. In some case, the soil can be taken as well-graded sand. I'll show that something also. Okay. Now, my dear students, when I told you already, if Cu is greater than 4, we call it as well-graded gravel. What we call? We call it as well-graded gravel. And remember, my dear students, if Cu is greater than 6, then it is called well-graded sand. It's called well-graded sand. My dear students, here, when you tell that the soil is well-graded or not, on what basis you are going to tell? For that, you will be studying about the Cu. What is Cu? Coefficient of uniformity. It gives you idea about the particle size range. From which particle, what is the minimum size of the soil particle to the maximum size of the soil particle. So, coefficient of uniformity will give you idea about the particle size range, my dear student. When I talk about Cc, what is Cc? For any well-graded soil, Cc should lie between 1 to 3. When the Cc value is between 1 to 3, then we call it as well-graded soil. Then we call this as well-graded soil. Now, as a geotechnical engineering, my dear students, we remember these points, very important. You can write it as a note. For a well-graded soil, okay, for a well-graded soil, both conditions of Cu and Cc should be satisfied. Sir, for a well-graded soil, both the conditions of Cu and Cc should be satisfied. For suppose, sir, you are telling Cu should be greater than 4. For suppose Cu is less than 4, but Cc is 2. If any one condition is satisfied also, then we treat it as poorly graded. If any one condition is not satisfied, then we call it as poorly graded. So, my dear students, I would like to tell you one important thing. For any soil to be well graded, it should satisfy both the conditions of Cu and Cc. If any one condition is not satisfied, then it is treated as poorly graded. So, this is a very important when you are solving the GATE question, because to find out CO, it is the ratio of D60 upon D10. To find out Cc, it is D square 30 upon D60 upon D10. So, what is D10? It is nothing but the effective size. So, what is effective size? It is the size of the sieve where only 10% of the soil particles are passing. Now, my dear students, I thought Srujana will ask me this doubt. Sir, you are telling when you are talking about A line, when it is above A line, you are telling it is clay. But below A line, my dear students, below A line, we have, below A line, it can be silt or it can be organic soil. Below A line, there can be silt or organic soil. Below silt, I would like to tell you, there is silt or organic soil. Now comes the question, how do you distinguish a silt or an organic soil? How do you distinguish silt or organic? Means how do you distinguish? So here comes the concept. We have some specified tests to determine the organic soil. So what is the tests are? Tests to identify. Tests to what are the different types of tests to identify organic soil? First one, we have the color test. How is the color, sir? How is the color of this? The color will be dark gray or brownish color. Please remember that the color will be dark gray or brownish. And as you know, the order of organic soils. Sir, if you can identify it is an organic soil, if it is not an organic soil, then obviously it is silt. So we will talk about organic soils. How to identify organic soil? If it is not organic, then obvious it is silt. So here, if the order is considered, what is the order? Order is bad order. But these are the kind of tests by looking you can identify. But there is a practical important point, Amma. You talk about liquid limit after oven drying. Sir, we have an important thing. If liquid limit after oven drying. If the liquid limit after oven drying reduces by more than 25%, this is a practical observation. The liquid limit reduces by more than 25 percentile, then we treat that soil as organic soil. So here lot of people will ask me, if the liquid limit reduces by more than 25 percentile, then we treat that soil as what? Organic. Suppose, see students, if you have a liquid limit, the liquid limit is equal to some 100 percentile, assume. Now, liquid limit after oven drying has made into 60%. Now, how much percentage it is reduced? 40% reduction. So, in this case, there is a 40% reduction. So, when I talk about 40% reduction, then we take this soil as organic. Srujana, is it clear, Amma? When the liquid, sir, see, the reduction is very important. Suppose if the liquid limit is 60 and the liquid limit after oven drying is some 50. So, how much percentage it is reduced? It is not 25% reduced. So, if it is not reduced by more than 25, then it is treated as silt. This is very, very important. You have to compare with the initial value. These students, most of the people will do this mistake. See, you have to know what is the profit and loss. Okay? If profit is what? Initial minus, like cost price, selling price minus cost. Cost price is nothing but profit upon the initial cost. Similarly, you have to understand the percentage reduction. That is initial minus final upon initial. So here, that is the reason to have a more clarity, I have taken 100%. Okay. Now see students, if we are talking about fines, what is fines, sir? Fines is nothing but where 95% are, fines is nothing but percentage of soil passing through 75 microns. What is percentage of fines means? 75 micron. Whatever the soil which is passing through 75 micron, we call that soil is nothing but the percentage fines. Suppose, my dear students, if the percentage of fines, is less than 5 percentile, if the percentage of fines is less than 5 percentile, then in this case, you talk about either well graded, because 95% of the soil is only one type. So in this case, you will talk whether the soil is well graded, or you will talk about the soil whether it is poorly. Are you getting, my dear students? So when you talk about the soil is well graded or poorly graded, there the fines are less than 5%. That means 95% are of same quality. I will tell you how it is. If suppose you have taken a blood, in blood you will have red blood cells, white blood cells, and like that. So what is the composition of red blood cells? What is the composition of white blood cells? Similarly, if you talk at soil, if 95% is one category, then we will talk whether the soil is well graded or poorly graded. Okay. If the fines are more than 12 percentile, in that case, you talk about clayey gravel or silty gravel. Are you following, my dear students? When fines are more than 12 percentile, you talk about clayey gravel or. Now here, my dear students, when fines are less than 5 percentile, you talk about well graded or poorly graded. If it is more than 12 percentile, you talk about clayey gravel or silty gravel. And remember, my dear students, when IP value is between 4 to 7 and fines value 5 percentile to 12 percentile, we talk about the dual nature. What is dual nature? Like I told you, SMSC, silty sand, clayey gravel. So you talk about the dual nature. Are you getting, my dear students? So please understand here, when fines are less than 5 percentile, you talk whether it is well graded or poorly graded. If the fines are more than 12 percentile, you talk about whether it is clayey or silty. When the fines are between 5 to 12, or if it is 4 to 7, then you talk about the soil that is dual nature. Clear? Now see, students, we also have a concept called activity ratio. Now see, students, what do you mean by activity ratio? Why do you want to study about activity? See, students, the question here is activity ratio is represented by the formula A is equal to IP upon percentile C, where IP represents the velocity index, percentile C represents the clay fraction, how much amount of clay is present. Okay. Now see, students, why do you want to study about activity ratio is the swelling and the shrinkage characteristics. The swelling and shrinkage characteristics of the soil. The swelling and the shrinkage characteristics of a soil are represented by a number called activity number. Remember, to have an idea on the swelling, and swelling is nothing but the bulging, shrinkage is nothing but the volume reduction. To have an idea on this, we are studying about the activity. If suppose for soils of specific origin, the activity ratio will be same. Now see, students, when the activity ratio is between 0.75 to 1.25, if it is less than 0.75, if the activity ratio is more than 1.25. In this case, it is low active soil. This case, the soil is having medium active. Suppose if the activity is more, then it will have more swelling. And here, if it is more than 1.25, highly active. Okay, imagine students, montmorillonite has almost value equal to 4. If you say it is more than 1.25 itself, you are telling it is highly active. It is more than 4 means very, very as highly. So, if I do the important points in today's topic, if I talk about the summary, okay, you have to talk about first the equation of A line. Is very, very important, students. When I talk about the equation of A line, how do you represent equation of A line is IP is equal to 0.73 into liquid limit minus 20%. And you should also go through plasticity chart. There can be a 1-mark question on this formula. And remember, my dear students, I hope this session will help you to clearly clarify all your doubts on soil classification. If you are really liking this session, please share this session to all your friends, and these sessions will help the students who are preparing. And I'm really thankful to IMS India GATE Academy. So here what I would like to tell you is, we are offering online coaching, offline coaching, and we are offering offline coaching at Vijayawada and also at Bangalore. You can visit our Bangalore center at Jayanagar, and you can visit our IMS Academy, GATE Academy at Vijayawada at Bench Circle. So we are offering my plan session, leadership programs, doubt solving portal, also 800 plus hours of GATE classroom, 12 sessions on my plan, and we are all giving you subject test, chapter test, multiple subject tests. I hope these sessions will good marks in your